Well, guys, we're on lesson 9-4, which is subtracting fractions using models. So remember from our video, we watched how we subtract fractions, and we use fraction strips, or we use number lines. So remember, for a fraction, if the top number is bigger than the bottom number, that's an improper fraction. And what that means is there's a whole number hidden somewhere in there. So that's how they modeled it with this fraction strip. Since that top number is bigger, there's one whole, which is 8/8. And then what else do we have? Well, we started out with 11/8. So that's where these guys came in right here. So this is actually starting out with 11/8. And then what happens? Well, we're taking away 2/8. So that's what they did here. They took those away. They took those two. And then what do we have left? We're left with 9/8 because I see there's 8/8 here plus 1/8, which then breaking up or using my model, we see that's one whole with 1/8 left over. So now let's jump down to number 1. In the problem on the top of the previous page, suppose one other 1/8 section was used to grow peonies. What fraction of the garden is now available for flowers? Well, if you remember, we started out with, or we had 6/8, and now what's happening is one other section was used to grow peonies. So we're taking away one other 1/8. We're losing one section to grow stuff. So we're left with 5/8. Now for number 2 through 5, use fraction for strips or other tools to subtract. Well, here we have 1/3, so I'm going to draw 1/3. And we're taking away 1/3, so bloop. So we're left with 0/3. Off to number 5. Here we're starting out with 5/5, so that's 1, 2, 3, 4, and 5, which we know is a whole. And we're taking away 2/5, so that's 1, 2. What are we left with? We're left with 3/5. Remember, that bottom number with fractions always stays the same, at least for 4th grade. So here, what do we have? Well, even before we draw a model, we know we're going to be left with 12ths. So now let's draw 7/12. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 7 of them. So I'm going to fill 7 in 1, 2, 3, 4, 5, 6, 7 12s. And we're taking away 3. Remember, these ones are blank because we don't have them. They don't make a whole because we only start with 7. So we're taking away 3. So that's 1, 2, 3. So what am I left with? I'm left with 4 pieces, 4 12s. Off to number 5. Well, so let's start out with 7/8. So we have 1, 2, 3, 4, 5, 6, 7, and then 8. So that's a little big. So let me shrink that down for us. And we start out with 7. So there's, oops, we're erasing there. So we have 1, 2, 3, 4, 5, 6, 7. And how many are we taking away? We're taking away 1/8. So even before we write it, I'm going to make my denominator is 8. We're taking away 1/8. So whoop, that one's gone. What are we left with? We're left with 1, 2, 3, 4, 5, 6. 6/8. Okay, now for number 6. They have this model for us. So let's start here. We have 11/12, which we see here's 6 and 5. So together that's 11, and we took away 5. So what are we left with? We're left with 1, 2, 3, 4, 5, 6. We're left with 6/12. Now number 7, they have a number line for us. We start out with 2 halves, which I see is here is 1/2, 2 halves. And we're taking away 1/2. They took that away. What are we left with? We're left with 1/2. Over here, same thing. The denominator will be 3 because it always is. We had 2/3 and we took 1 away. So what are we left with? We're left with 1/3. Now over here, 4/5 take away 2/5. So I'm going to do what they are doing for this one. So here's one whole, and then underneath we had what? We had 4/5. So 1, 2, 3, 4. So this last piece right here would be what? That would be our missing 5th to make a whole. So here we have 4/5, and we're taking away 2. Oops, I did that wrong. I have 5/5, and I need 4/5. Let me start that over. So we'd have 1, 2, 3, and there's our 4/5, this missing part over here. That's much better. Okay, and we're taking away 2/5. So that's take away 1, take away 2. What are we left with? Well, we're left with 5ths, and we're left with 1, 2/5. Okay, over here, 17/10. Well, maybe you've noticed a pattern here. Again, that bottom number is always 10. And then that top number, we're going to draw our model. So here's 10 tenths because we have 17, which is one whole. And then we have what? Underneath, we're going to have 7 tenths because this is 10 tenths. 2, 3, 4, 5, 6, 7, 8, 9. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. And we have 7 of them. So all of this would be colored in. And then 1, 2, 3, 4, 5, 6, 7. And we're taking away how many? We're taking away 3. So 1, 2, 3. So what are we left with? Well, we're left with one whole from this top guy and 1, 2, 3, 4 tenths. So 1 and 4 tenths. Over here we have one whole, which would be 6, 6. And then we'd have what down here? 1, 2, 3, 4, 5, and 6. So we'd have 2 6 left over because this is 6 6, so that's 2 6. And we're taking away what? We're taking away 2 6. So what are we left with? We're left with just one whole, or 6 6. Now for number 12, again we're going to start out with 6 for our denominator. We have one whole, which is 6 6. And then if we have 6 6 to make 9 6, we'd have to have 3 6. So 1, 2, 3, 4, 5. So here's 3 6 plus 6 6 is one whole. And then we're taking away 1 6. So we're taking away that one. What are we left with? We're left with 1, 2. We're left with 2 6. So what do we have? We have one whole and 2 6. That one whole again coming from that whole we started out with. Number 13 now. Ooh, this one's different because here you'll notice we have 10 tenths for a whole, then we have another 10 tenths for another whole, but then we'd have what? We have 1 tenth left over. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we had just this guy left over. And what are we doing? Well, we're taking away 1 tenth. So what do we have? Well, we have 2 wholes left over, or the same as 20 tenths. Either answer was acceptable. And our last one, 1/5 minus 1/5. This one, we're not even going to draw a model because we know whenever we subtract one number and the exact same thing, it equals 0. So now let's head on to the next page. Model with math. What subtraction problem did Miles show using the fraction strips below? What did he start with? Well, he started out with 8, so that part's easy. And we start out with 1, 2, 3, 4, 5, 6, 7. So he started out with 7 eighths. And then how many did he take away? So here they're showing with the arrow, and ours we're showing with the X's. But how many did we take away? We took away 3, not equals. We took away 3 eighths. We took away 3 pieces. So what are we left with? Well, we're left with 1, 2, 3, 4 pieces. Is 4 eighths, which is the same as a half. Number 16, using only odd numbers for the numerator. Remember, numerators are the top numbers. Write 2 different subtraction problems that have a difference. So that means has an answer that's equal to 1/2. Remember, you can find equivalent fractions for 1/2. So I'm not sure where to start, but it gives us this hint right here. You can find equivalent fractions for a half. So let's start there. So 1/2, that's the same as 2/4. It's the same as 3/6. Is the same as 4/8. Is the same as 5/10. So there we go. So now let's begin. We need something plus something equals a different something, and then something plus something equals a different something. So let's start out with just the next fraction here. So let's try 2/4. Well, the only way you get 2/4 that we can see easily, there's actually several ways, but what we're thinking is 1/4 plus 1/4, because we need this numerator to get to 2. But notice they're not different. So we have to switch to something else. So it looks like 2/4 isn't going to work for ours. So let's try 3/6. So how do we get 3? Well, 1 plus 2 equals 3. So that pile number can be 6. And then that's one way. So what's another way? Well, here, let's just go to the next one, be 4/8. So how do we get 4? Well, we can have 1 plus 3. So it looks like we have them, but let's go back and read our directions just to make sure. It says using only odd numbers for the numerator. And notice with our 6's, that's not an odd number. This one was, but the 6 wasn't. So we have to fix this one. And now what do we get? Well, let's head to the next one in our number line. So we did 4/8. Let's do 5/10. So how can we get 5/10? Well, that would be 1 and what? 1 and 4. But that doesn't work. So let's try maybe 2 and 3. But notice they're not both odd. So it looks like we have to go to the next one even. So that would be 6/12. So what do we think for that one? 1 and 5. So it looks like we're good with that. So now let's read the directions again just to make sure. Using only odd numbers for numerators, write 2 different subtraction problems. And see, we forgot that. So remember when you're doing your SBAC, you're going to think, wow, I did this hard problem. And then you're going to be like, oh no, I made a mistake. And so if you read it carefully that first time, you're not going to have that mistake. So instead of adding, because it wasn't asked for the sum, we have to subtract. So now we have to go all the way back to again, and let's start. Well, those 6's seems like they worked well. So let's just see if we can do that with our 6's. So what minus what equals 3? Well, 5 minus 2 equals 3, but notice that's not an odd number, is it? So let's head to another one then. Let's just try at the very beginning our fourths, so 2/4. So let's see, what minus what equals 2? Well, 3 minus 1 equals 2. So that one is good. And it's an odd number, and it's subtraction, and it equals a half, because 2/4 is equal to half. So let's head to our next one. Well, this 8's, remember, it worked over here. So let's try our 8's over here. What minus what equals 8's? So let's check that. Well, the obvious one would be 5 minus 1 equals 8. So there we go. And with that, we are all done. Now, you could have had some fancier ones. Like you could have actually done like 11/8 minus 7/8 equals 4/8. But we'll just keep it simple for ours. Number 17. In Kayla's class, some of the students are wearing blue shirts. 6/8 of the students are not wearing blue shirts. What fraction of the students are wearing blue shirts? And show your work. So here we have this problem. We have a whole class. So I'm going to start by making a fraction. This is my whole class. And it's telling me down here with my denominator that there's going to be 8 total pieces. 1, 2, 3, 4, 5, 6, 7, and 8. And how many are not wearing blue shirts? So we'll just say, we don't know what they are. We're going to say they're just green shirts. So that's 6/8. 1, 2, 3, 4, 5, 6. So that's how many are. So looking at that, we start out with what? We'd start out with 8/8 is our total, and we're taking away all of these non-blue shirt people. So that's taking away 6/8, which gives us 2/8. We could have also just filled in the colors like this and seen, well, that's also 2/8. So how many students are wearing blue shirts? 2/8. Number 18, in exercise 17, which is this shirt one we just looked at. What number represents the whole class? How do you know what fraction to use to represent this number? So 1 represents the whole class. And remember, we showed 1 by what? We showed 1 by 8/8 because they're equivalent. Since the fraction of the class not wearing blue shirts is 6/8. In order to have a like or common denominator, I used 8/8 to represent a whole. Now, off to number 19. Rick shared his bag of grapes with the friends. He gave 2/10 of the bag to Melissa and 4/10 of the bag to Ryan. What fraction of the bag of grapes does Rick have left? Show your work. Well, he has a whole bag, so a whole bag is 1 whole bag, which is the same as 10/10. And we're using tenths because that's the denominator they give us. So let's start out by doing 10/10. So here we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. And how many did he give to Melissa? Well, Melissa we're going to make as red. So he gave 2/10 to Melissa. We're going to make Ryan green. 1, 2, 3, 4. So how much does he have left? Well, we start out with 10 tenths, and we took away Melissa's because he gave them away, and we took away Ryan's because he gave them away. So what are we left with? Well, we're left with 4 tenths, which we can easily see here is 1, 2, 3, 4 pieces. Oops, but I did 2 4s there. So he's left with 4 tenths of the bag. Teresa gave away 8 baseball cards and has 4 baseball cards left. Write a subtraction problem to show the fraction of the baseball cards Teresa has left. Well, first we need to figure out the total number of cards, because remember, she starts out with a collection. We have to figure out the whole, her total collection. Well, here we have 8 plus 4, because she had 8 she gave away, she still has 4. So it's going to be 12. So we need to break this up into 12 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So let's check. She gave away 8, so that's 1, 2, 3, 4, 5, 6, 7, 8, and she has 4 left. So it looks like our model is good. So what did we start out with? Well, we start out with 12 twelfths, because that's the whole. And we gave away 8 twelfths, and we're left with 4 twelfths. And here we have our subtraction problem, and we have our fraction. So it looks like we followed all those directions. So now to 21. Audrey wrote a subtraction problem that has a difference of 1/3. Which problem did Audrey write? Well, here, 2 halves plus 1 half is 1 half, so it's not A. 5 thirds minus 3 thirds is 2 thirds, so it's not B. 4 thirds minus 3 thirds is 1/3, so it looks like it's going to be C, but let's just check the last one. 5 thirds minus 1/3 is 4 thirds. So yeah, our answer here is C. Now number 22. Kinsey wrote a subtraction problem that has a difference of 10/8. So remember, that means our answer is 10/8. What problem did she write? So let's check. 28 minus 10/8 is 10/8. So it looks like it's going to be A. We'll check the others. Here it says difference, and I see this is an addition problem, so it's not B. We're going to have to check it. 10/8 minus 4/8 is 6/8, which is not 10/8. And 6/8 minus 1/4, well, that doesn't have like denominators, so we're not even going to bother with that one. So our answer is A. Good job, you guys.